Hey, how's it going? All right, so the question was adding stretchiness to spline IK. All right, let's try this out. So I'm going to create a curve. So let me just do this. It's just a 3-point curve. Although I'm going to add maybe 5 points to it. All right, so I got my curve. This would be like a strap for a backpack or something like that. The root's going to be at the top. And next thing I'm going to do is create my joints along there. So I'm just using Maya's bonus tools for this. You probably already have your joints, so you don't have to worry about this. But let me just go into... Now the bonus tools are not part of Maya. They can be downloaded for free from the Autodesk website though, and they're very, very useful. There's a lot of cool things you can do in here. Like, well, stretchy, you can just do that right here, but you can create joints along a curve. And let's see here, I don't want to have too many joints because it's still going to take a couple seconds to do what I'm about to do. So I'm going to use maybe 6 joints. And I'm just going to add spline IK, so it's going to generate everything for me. So I've got my curve. And on that curve are my joints, and if I were to move things too far, obviously you can see that the joints are separating from the bottom there. All right, and I'm just going to simply add in some clusters for this. So deform cluster. Missed one. I'm not going to go and add controls and all of that stuff, but the clusters will be useful. So let's see here. Because basically, I want to be able to have everything stay locked down, right? So I want this locked here, and I want this locked down here. I'm going to increase my joint size, so let me just quickly do that. Display animation, joint size, just so these guys are a little bit bigger, easier to see. All right, so to add stretchiness, we're going to have to go into our node editor, and there's a few things we're going to have to add in here. So we're going to have to add in joints. Now, there's a couple ways we can do this. One is using the translate of the joint. Now, the translate, though, as you can see, when I move the translate, it'll slide along that curve. The problem being that we would have to match each of these values, and each one of these is potentially a little bit different. You can see here that each one's slightly different here, so that's not going to be useful. I would actually go ahead and translate, but it's very time consuming. So the other option is to just simply scale. So scale, as you can see, as I scale, it also slides everything along that joint. So, it's kind of an easy way to do it, because the cool thing with scale is that there's a lot less setup involved, because it's just the one attribute, and every joint will have their X value at 1, which makes it easy to do what we need to do. So when we're attaching scale, we would attach it to all of these joints, except for the last joint. And this is going to allow us to basically stretch everything along that curve, so just in X. So I'm going to load in all of these joints, not the last one, we don't need that one. So add all of these in. There they are there. Now, for this type of thing, we don't need to have any kind of condition, because basically we want it to stretch and grow depending on how close or far away we're getting. I'm thinking might be best. Now, do we need a condition? No, I think we're just going to go completely stretchy, 100% stretchy. All right, so the next thing we need to do is bring in our curve. Now, for the curve, we need to have a specific node associated with this, because it's this node that will give us the measurement information that will be used to scale the joints, and it's called an arc length. And we can attach an arc length or create an arc length because it's not actually part of the curve by default. So you just select your curve and then you type in arc, len, so it's a short form, minus ch1. And it's going to create a curve info node. And on the curve info node is the arc length information, which is just basically the measurement of the length of the curve. And you can see that right here. Right here, this arc length value. So if I were to grab one of these guys here and move it, so the arc length was, as you can see, it's 9.116. So if I were to take one of these clusters and move it, now my curve is larger, and you can see that is giving me an updated information there. Okay. So what we need to do is create just a very simple way to get a multiple, a clean multiple, so that when nothing's moved, you know, everything stays the same position, right? And when things start to move, then it's going to scale those joints. To do this, we're going to have to create two multiply divide nodes. So multiply divide. One's going to be a multiply node, and the other one's going to be a divide node. So this one will be our divide, and this one will be the multiply. Okay, and we're going to be connecting our arc length Well, you know what? Do we need the divide node? I guess that's the question. I think we can almost get away with, just because we do need the divide node, because essentially what we need to do is have a value of 1 going into these joints, because you know we are going to be replacing the static scale x value of 1 with a dynamic value of 1. So it's a value of 1 that will change depending on the length of the curve. Now, if I were to look at this arc length, this value is 9, right? So if I were to feed this directly in, my joints would scale by 9 units. So it'll just kind of blow out the curve essentially. So what I'm going to do is I'm going to go through a dividing process here. So I'm going to take the arc length, and since we're going to go into scale x, I'll put it into x. And I'm going to be dividing this number by itself. So any number divided by itself is 1, right? And I'm going to take the output x, and I'm going to put that into the multiply. So I have to make sure that this first node is set to divide, so that the output, you can see here, is 1. And I think this is the right order. We might have to switch this though, but we'll see. We'll find out soon enough. So I'm going to take the output x, and I'm going to replace it with the x value in each of these joints. So, you know, the more joints, the longer this will take to do. Here, let's see if I can just, well, I'll just do this. That was really tiny. I'm going to see if I can just kind of, there we go. So output x into, oh, you know what, I just put it, I want scale. Normally I would use translates, but again, just because it's very time consuming, this should be just as stable. All right, so output x is going to go into scale x, and I'm just going to connect this. There we go. See, not too long at all. Now, if the result is the opposite of what we need, we'll reverse the divide order. Okay, so that's basically it. So we got our arc length going into the divide, which gives us a value of 1. And then we've got it going into the multiply, which is going to replace the static scale x with the dynamic scale x. So there's a value that will change depending on the length of the strap. So good news, nothing's changed here. right? If I were to select one of these, I can see it has a dynamic value in there. So now when I, ooh, look at that. Look at that. All right, so now when I move over this, my joints, for the most part, do exactly what they need to do. Now, if I had more joints, I would get a better result here. Just this one isn't, it's not very evenly spaced. So it would give me a nicer, cleaner result if I had cool. Now, one thing you could do if that end joint is bugging you, you know what? I don't think, if you had equally spaced joints, I don't think that's going to become an issue. All right, that's it in a nutshell. At least it won't tear apart. Let me know how it goes, and cheers.